The purpose of this talk is to address something that some years ago I never would have dreamt would ever need addressing. When Oracle Database brought PL/SQL into the toolkit down there in the database, this was in the early 90s, and it was a sort of defensive measure because Sybase had them and Oracle didn't, and it was a very serious threat to Oracle's survival, so we all were led to believe. And the reason, of course, that it was such a big thing, Sybase having them and us not, was because they were so critical. They were so critical in the world of the suddenly arrived client-server computing, where suddenly round trips seem to matter. And as far as I've understood, nothing has changed in the laws of physics that make a high number of round trips between one, place and one other, back and forwards to the Oracle database, suddenly unimportant. Yet the common perception is that they are, and whenever you go to larger meetings of this sort and you hear the famous names, Wood, Lewis, Carrie Millsop, that lot, they're always going on about customer X who they visited, who had some phenomenon of high frequency back and forth, and then you find out they're not using PL/SQL. And then you probe a little bit more around the place, scraping the surface of that and asking a little bit more why is all this going on, you find there's a viewpoint that says, it's always this type of vocabulary, that business logic should not be in the database. It's difficult to find this convincing argument that flows from that, but some things you hear are can't get the staff, and other things you hear are want to be platform independent, vendor independent. This is while they're getting into the database by robotically generated SQL that comes out of something made by a vendor, but never mind that. Anyway, so having got more and more brought to the boil about all this lot, I decided that I should write the charter, why use PL/SQL, and prepare it in such a way and deliver it in such a way that in the first round, people who were already devoted to that way of thinking would have ready-made an argument that they could use. Now, I will ask now in a moment what your general daily life is like, to see how much of what I say will be news, if any of it. So just let me see who in the last week has actually typed up some PL/SQL as part of their ordinary day job. Okay, who, now the counter proposition, I should have asked who is quite happy putting up their hands when I ask questions. Let's just get that one out of the way first. Yeah, so most of you are not in the survey. So who has never typed any PL/SQL ever in the last year? Okay, all the shy people. Right then, so I'm assuming then that I won't tell you anything you don't know, and then what you will hear will be how to argue this. So the final question before I get off is, off into the flow, is have any of you met this no business logic in the database mantra?
Absolutely.
Yeah. Okay, well, that's fine then.
I wrote a slide today for
Yes.
the current client,
Yes.
explaining why they shouldn't be doing this in Java.
What this? What you mean this? What you?
Their business logic to copy data from one
Oh, I see.
schema
Yeah.
to the next schema
All right.
via Java.
Oh, okay. Good. Okay, fine. Right then. So, without further ado, I forgot to say who I am, but I'm Bryn Llewellyn, and I'm a product manager, and I'm lucky enough to work in Oracle headquarters, surrounded by the thing that makes it nice is I'm surrounded by all the famous people who build the critical bit of the Oracle database. This SQL compilation and execution, PL/SQL compilation and execution, the optimizer, the library cache, more recently multi-tenant, a little bit before that, the edition-based redefinition, parallel execution, partitioning, all that stuff. It's all on the same floor where I work, so it's a dream position. I could give you the slides I'm about to use, but my own feeling is they don't really tell you anything unless I'm standing up here, and therefore there's a white paper, and that's the point, and it's easy to get to with the most middle, with the simplest of all bootstraps. If you can remember oracle.com/ I'll pronounce it this way once and only once, the wrong way, PL/SQL. It's just you can't have a slash where it ought to be because it's in the syntax of the URL. If you can remember that, then you can navigate to this blog. There, you know, the PL SQL and EBR blog, and there you'll find the abstract of this talk and a link to the paper. And just to show you I'm not fooling, that's what I'm talking about there. And then that's the blog post with the abstract that's more or less in the, it is, I copy and pasted it, you know, Mick copied and pasted it. And that, you know, just to give you the flavor, you know, the design of an application that uses blah, 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 PL SQL's purpose is to blah, 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 blah. It's common to lead with discussions about performance, but it would be meaningless to try to improve the performance of a totally boxed up application. And so it goes on. So that now this is utterly irrelevant, and now we can start. And by the way, they force us as Oracle employees to use, you know, the style of the year. At least they don't force me not to use PL SQL, but they do force me to use these slides, and normally I hate it all. But this picture, this compulsorily inserted picture, is very useful here. It's very apposite, because what you see there is clearly a forceful, intelligent, strong woman, very much in command, very intelligent, in process of explaining things, and yet, despite all those admirable qualities that she has, she is not able to disguise a kind of incipient tendency to explosion of impatience. It's kept under control, but nevertheless. And you can see why, because she's got two absolute dim and the point's not sinking in. So it's a very good visual metaphor for this talk. So then, here we go. This is basically the abstract, but it's a nice forceful way to start. It says, controversially, large software systems must be built from modules. And then it prompts one to wonder what a module is. A module, and then you hear these words, don't you? You don't hear the word module unless you hear the word hide, unless you hear the word interface. A module hides its implementation behind an interface that exposes its functionality. And I've been hearing people say that since I was born. It's hand in hand with computer science, and it's computer science's most famous principle. Now, would anyone in this room say that that basic idea is just total box? Would anyone dare to? Do you generally think it's a good scheme? Right, a good principle. That's what you lead with. You know, this person with whom you're arguing would have to provide some arguments about what's wrong with that idea. Of course, there aren't then. Now, let's just space it. Let's just apply this to what's interesting for us. If you've got an Oracle database in the picture, you'll probably have some other stuff too. Not necessarily, well, yeah, I would think pretty much necessarily. And in a kind of application architecture that we hear a lot about, there'll be some collection of stuff that's generally called the application server. There might be things, connection pool stuff, there probably is these days, and there'll be various things to protect the inner world from the outer world, firewall stuff, and so on. And at some coarse-grained level of decomposition, we're looking for the modules. It seems to be inescapable that among the things I mentioned, the Oracle database itself is a module. Yes? Does that sound plausible to you? Because after all, this whole theory of modular software construction implies hierarchical decomposition, starting at the top and looking for the coarsest grained, most obvious units of organization. And the application, because it's using Oracle database, is all about persisting stuff. So the thing that's all about persistence is clearly a module. Now, considering its operation, ultimately you're persisting stuff. Where do you persist it? You persist it in tables. How do you get it in and out? You use insert, update, delete, probably commit, and select. Now, what are those things? You know, the tables that hold the stuff and the basic low-level thing that operates upon it. It sounds to me like a perfect match for the notion of implementation details. Now, if you want to hide all that lot behind an interface, the word interface tends to imply something that's oriented to the functionality, and languages like C and Java, and not all the ones we've heard of, most of the ones we've heard of, I'm not thinking of Lisp or anything, are oriented towards subprograms. And it's conventional to think of a sub-program set as specifying an interface. How do you do that in Oracle? PL SQL. So it seems to me that point 1 leads to point 2, as a simple application of the principle. We'll go at it more carefully in a moment. So here's a funny thing. I travel around like young Tim over there, and we meet all sorts of people and talk to them. And I meet lots of people who are really, really just doing it still. And funnily enough, the developers and the end users, they're all happy. They're happy with the correctness. That's the most important thing. It's, not getting wrong stuff. And when they want something new, it's relatively painless to bring it in. When bugs arise, it's relatively easy to fix them. And it has good security and performance kind of meta properties on the top of being basically right. And the converse is true. You do meet people who strictly adhere to this no PL SQL paradigm, and their applications have problems in all those areas, and end users suffer. There seems to be an obvious reason for that. And exactly this session is intended to provide you with unassailable arguments. If there were any skeptics in the room, then I would think that they would see the light, because I would demolish them if they didn't. But there are none here to try it out on. So then, in spite of all that, we see this. And believe it or not, at Open World, where they were celebrating SQL and on and on and on, this was put up as a good thing. But this is a tragedy, because notice that the SQL stalk is sticking out through the roof, and all the other things, the ones you've heard of, like Python and this sharp and that plus plus, they are all there, and there's no trace of PL SQL. The only thing we can deduce from that is all those, oceans of SQL that are happening, the insert, update, delete, and commit, and select, they're happening independently of PL SQL. Well, that's a bad thing, not a good thing. And this is what we want to attend to. So then, here's how to approach it. A little bit more on what I already said, just applying those age-old principles to the systems we're interested in. Then a little aside, just to make sure that your audience, all appreciate the very nature of SQL, what it is and what it isn't, and how you make it go. And then we'll be ready to put some vocabulary on this. We've already met this no PL SQL term. Sorry, I can't even pronounce it right. And we'll be ready to name the thick database paradigm. And the rest is detail. The next point is something new in 12.1 that removes some potential reasons that naysayers could have argued with. The next number 5 there is just a rehearsal of all the things that distinguish doing SQL out of PL SQL from all other ways of doing it. Phenomenal semantic power of expression, compactness, the whole stuff. Good performance, I'll remind you of those. And then 6 and 7, 2 more demolishments. People used to witter on about, well, it's all very well, but you can't change it when you need to. Of course, you have been able to do that since 2009 with the addition-based redefinition. And finally, getting everyone a sandbox where they can work now is very practical. All can be done from the SQL Plus script with a little bit of not very difficult work to set things up using pluggable databases. So then we can conclude. So then, this bit. What are the modules? I already said the critical module is the Oracle database. In our discussion, we can not pay particular attention to the others because that's the one that interests us. So business functions matter. The canonical example of a business function with respect to the kind of stuff we're talking about here is the transfer funds function in the context of an application whose purpose is to manage all the stuff within one bank. Perhaps that's a little bit old-fashioned, but never mind, it'll do for our discussion here. And I do such a thing. Definitely within my own bank, I've got a current account and a savings account, and I might move stuff typically always in one direction, so I can spend it, but you know what I mean, sometimes going both ways. And one thing is true, when I do that, when I move money between my own accounts, actually I got 3 and I sometimes jiggle around, I better have the same total when I'm done as when I started, yes, before I started. None of those statements have got anything to do with tables or anything, but they are very much about the functionality. And the basic functionality is characterized rather straightforwardly by the identification of the source account, the target account, the amount of money. Those are the critical things, and there's usually other stuff like when do you want it done, now or later, and do you want a little memo to put on it, why you're doing this, that kind of stuff. And if it goes wrong, you might get an obvious useful message like, sorry, you can't do this because you're $18.53 pounds short, euros, whatever it might be. So that's the business function, and they matter, right? Because obviously if you did that and you had less than when you started, something would have gone wrong. And someone has got to make sure that it doesn't go wrong. And ultimately, it's all about holding stuff. So whoever is holding the stuff has to have the authority to make that whole business function do what it's supposed to. If that authority is held somewhere distinct from where the actual facts are, well, you just got a total mishmash, and you don't know who is doing what wrong if something does go wrong. So that seems to me unassailable. Table designs can change. Obviously, we can think of all sorts of ways of arranging this solution to the problem I mentioned. Maybe some of them you dismiss as silly, but that doesn't mean to say you wouldn't find them. There could be a table for every kind of account, for example, reflecting the fact that there's this kind of account and there's that kind of account. They have different kinds of details. Or someone might have read a few books and there might be one table for the accounts where all this stuff is expressed in some kind of difference in columns and whatever scheme you use for subtyping, all that kind of thing. And sure enough, they can change in all sorts of ways. At the microscopic level, you realize some column is too narrow or doesn't have enough precision. At the higher level, you realize that you could have done a better job of basic problem breakdown. So the functionality, though, doesn't change. It's just the illustration of the principle of modular software design. It should be possible to change all that stuff without the outside world who are using these functions knowing you're doing it. Right then, as I said, responsibility needs authority. Not like in my job where I seem to have some supposed authority and some supposed responsibility and no authority to make anything happen. In this world, you actually really, really, really need the two to go hand in hand, it seems to me. And the conclusion, it seems, is inevitable. You have to encase the database in a hard shell and let ordinary people who are wielding these business functions by virtue of facts they've gathered from UIs or robots or whatever go into this only through fixed holes on the shell. In other words, what sometimes in security speak they call a tiny attack surface. A surface which is intended exactly for one purpose, that and only that. So here's one way of doing it. Tracy on tracks. When I drew this slide first, it was Tina on tracks. But then I discovered that, oh dear, that was last month, and now it's Tracy on tracks. The tracks framework has moved from V1 to V2, more or less compatibly, but the scheme. The idea is that you use some sort of fashionable domain-specific declarative fashion, some graphical, some sentence-oriented, to say what you want in terms of functionality and the information you want to operate upon, and then that's all in terms of the language that the framework gives you, and then you can stick in the middle anything you want. There's the latest, no anything at all. It's even better than no SQL. Yeah, exactly. It all happens just by faith and a good following wind. And the basic idea here is exactly that. The protocol that deals with the persistence engine is robotically generated. And we hear, don't we, these horror stories that, Tom Kite was famous for coining the phrase slow by slow, where he thought of people doing row by row by row. That's not slow enough for the modernists. They want field by field within row by row within a row. And that's the kind of side effect of a mixture of, wrong thinking, together with this lowest common denominator idea, that the protocols are generated robotically and they must be able to operate on it if you care to plug in there. So that's, it's a fine idea. Don't misunderstand me. I think it's a wonderful idea, and I'm waiting for it to reach a later stage of maturity. But I'm not going to talk any more about that. I'm going to talk about the Oracle way of doing it, the time-honored way of doing it, and we'll take this sidestep. What is SQL and how do you make it happen? So this is something we hear all the time. A SQL statement describes its intended effect. It's famously a declarative language. You don't say how to do things, you just describe it. What can it describe? A relation, in the modern day sense. That's what you get, select this from that. And without getting sidetracked by sort of quasi-object type of thinking, thinking more classically, the relation is a set of, it's a tuple, isn't it? The relation is a set of tuples, and the tuple has scalar values. That's one of the founding principles here. And every member of this relation has the same shape. That's the whole thing. Well, in real life, if you want to see a master in its details, that's not that, is it? That's not a set of identical shaped tuples. It's something different. So clearly we can see SQL doesn't have unbounded power of expression. It's good for what it's good for, but it doesn't go beyond what it does. Does that make sense? Obviously, when you delete something, you're still identifying a relation, and then bang, it's gone. When you insert, it's the same. When you select, you get it back in your hands. But it's always the same thing. You just all these froms and wheres and havings and everything, and out comes a rectangular guy, a relation. Right then, it seems to me that the next point is obvious from 2 points of view. One is the semantic point of view. If you want to produce a master detailed thing, you've got to get the master and its details. If you do a join, which is famously the most effective way, efficient way of getting the facts, you'd be saying the same boring stuff time and time and time. There's got to be something, some if then else, something to present it in a comfortable fashion. Or if you prefer, you can program your own nested loops, but we won't get into that. So the other thing is just this rather strange fact that unlike other programming languages, a SQL statement is just there. It doesn't have a name. You can't give it a name. It could be in a file, which you give a name to, but now how do you make it go? You can't compile it up and store it as MySQL executable and then run it tomorrow. It's just not like that, is it? Not in any vendor's scheme. The reason it's not like that is because it's famously declarative and it has to work out what to do in the environment of all sorts of, statistics that it has in hand. That's all famous. So the way you make it go is basically you get the text, which by all means is on a file, or maybe just there the literal in the program, or maybe spirited up in the program from fragments, but it's text. And then you microscopically do stuff with it. You give me an environment in which to do my stuff. Here's the text. Is it good? Both with respect to spelling and matching things in the real world. And then if it's a select statement, oh, by the way, I'm selecting this stuff, and this is where I want to go, and on and on and on. And then it'll have placeholders in it, and here are my actual values. Please bind them onto that. Now go. But nothing's yet happened, and now get this bit, now get that bit, now get that bit, and then on and on and on. That's basically how SQL is done. You all know that, don't you? That's what you could call the sub-program, the subroutine approach to doing SQL. And some languages don't go beyond that. That's all they've got. They've got different vocabulary, things like prepare and so on floating around, but it's this basic idea that we know and love from DBMS SQL. Okay then. There are better ways, and we'll see, but there's no getting away from the fact that you need this if-then language for 2 purposes. One, just to get the assembly of things to happen, because the SQL statement is so atomic and doesn't give the generality that you want. And 2, you've got to make it go anyway. Right then. Now, if we're going to choose our language, there are 2 dimensions of criteria. One is, how good is it at doing SQL? Well, every language that can do it at all has got this subroutine approach. Historically, we had these pro-Fortran and things, and they seem to have fallen off the radar. And it seems that the only thing that survived that has intrinsic extra language features for doing SQL is PL/SQL. The rest have the sub-program approach. And we'll see when we go through the various language features that PL/SQL has, that they're very, very important. So that's one way to choose, and another way is where is it going to be running? Well, there's only two places it could possibly be: inside the database or not inside the database. If it's inside the database, then you've got a hope of this hard shell. If it's not, you haven't. The database has to be exposed, its blood and guts has to be laid bare so that microscopic inserts, updates, deletes can come from the subroutine-oriented, not that it's necessarily has to be like that, it could have been different, but it isn't. The microscopic statements have to come in from the outside world. Okay then, well, it seems to me we've got an inevitable conclusion. Let's just summarize. There's the no PL/SQL approach, which exactly says the database is going to receive only insert, update, delete, commit, presumably rollback, and select at runtime in a typical application. And these are going to come in from the outside, and everyone's going to go in, out, in, out, in, out, in, out. And the outside guy is going to take responsibility for making sure that either everything happens or nothing happens. But we have the thick database paradigm, which is the opposite. And here it comes. We'll start on the inside. That's meant to imply your tables. And the white ring, leaping to something you understand, is that that's the data schema. And here comes the code schema, where the programs who do these microscopic things are located. And it's definers writes PL/SQL, and you know the story about granting the appropriate things. So if a client-side developer was told the password to the grey ring, but not to the white ring, that wouldn't quite be what we want, because since the grey ring has the authority to do the things in the white space, he'd still be able to. But it's, as you know, trivial to fix that like that. And that is the access schema. And the point is that the access schema has no privileges to operate directly on the data. It has only execute. And it has only execute on those items in the grey ring that you have identified as the ones that define the interface. Yes? This is a completely familiar scheme, the three schema model. Obviously, you can get more fancy than that. You can have your data spread among many, and you can have lots of ones for your code, and you can differentiate between auditing and the real stuff. But that's the bare minimum, the essence of it. And that pink ring, it is the hard shell, isn't it? The database hides its internals completely, and the only thing that you can see when you know the username and password of the red ring is the units who define the interface. Okay. Typically, the red ring contains private synonyms to point to the stuff, but that's not necessary. It's just a kind of luxury thing, and I'm just choosing to call them insubstantial. And as you know, if you log on to the red ring and select all sorts of stuff, do whatever you can see various things in the dictionary, and in the all this, that, you'll be able to see your interface. And if you select from all source, you'll be able to read the package specs. We're assuming people have used PL/SQL properly, and there aren't any free-floating functions and procedures. And is it a bad thing that you can read the package spec of the things you're supposed to call? No, it's a bloody good thing, isn't it? That is exactly the interface contract. That's your doc, better than the doc sometimes a human being would write. Best of all, if it's just the code with some ordinary markup, so that it's functioning both as the code and the doc. If you select from all source and try to look at the package bodies, you can't. You know that, I'm sure, that execute lets you read the spec, but not the body. Right then. So that's brilliant, if you ask me. And now here come the outside guys, just as before. And from the point of view of them, it's the same story. But the big difference is that the database now owns the authority. You with me? Does that make sense? Yeah. So then, this thing here is the actual code that's the metaphor for the thick shell approach. You know, in the no PL/SQL approach, you allow insert, update, delete to come in. Here, the insert, update, delete got nothing to act upon. This is the only kind of SQL statement that's allowed. Now, for some reason, not everyone immediately sort of internalizes the idea that an anonymous PL/SQL block is a SQL statement, like any other SQL statement. It's a kind of super statement in a way, because within it you can end up doing any of the other things we've talked about, including creating tables or dropping users or anything. But even so, it's a SQL statement, and any if-then-else language that's got subroutine support for doing SQL can do one of them. Right? So there's no can't do it aspect to it. And that is the assertion of a thick database, that you shouldn't do anything but that. Okay then. And that there is, the recipe for some insert thing. You gathered some facts, not too many, but 100 facts or something like that from the end user, time to persist them. So you just bulk insert what you've got, and something comes back to say how well you got on. Now then, let's explore that just a little bit more, because as you know, in operating ordinarily with PL SQL, these bulk things are very often very important, and the source for a bulk insert or update or delete is a IBI of records, as we call it, an index by PL SQL integer table of records. It's hard to pronounce. IBP, it comes out as IBI, but you know what I mean, an IBI of records. That's the canonical PL SQL representation of a row set. And also for select this and that, bulk collect into. That guy is an IBI of records. And in this, it's implied that :rows, that placeholder, stands for a formal which has that data type. But we have to bind to it. So sadly, up through and including 11.2, you couldn't bind from any of the client-side languages because no one had set it up. You could only bind to placeholders who stood for SQL data types. And if you wanted to communicate a row set in a comfortable fashion, you'd have to transform it in the world of PL SQL into a nested table of ADTs, where the nested table and the ADT are declared at schema level. That's not impossible, but it feels like going around the houses. It's a bit ugly, and it doesn't improve performance either. But new in 12.1, I don't know if you all realize this, but now the basic OCI and the plumbing that goes all the way through to the SQL world has been upgraded so that you can bind to a placeholder in a SQL statement something of an appropriate data type in your host language that will match onto a PL SQL only data type. Okay? Did you all know that? Or was that news to anyone?
So you don't have to use all that Oracle type translator rubbish anymore that was around years ago?
I believe that's true. Yeah, you don't have to use that. Except that, if I understand you correctly, there are ways, semi-declarative ways that you can use things to get into your Java world, the right stuff, by inspecting the PL SQL spec that exposes all that lot. But you don't have to wrap things in artificial ways. Yeah. And that's huge. And sadly, it took us until 12.1 to bring it in, but now we are in 12.1. Right then, that was that point. And I'm just saying it's huge, important improvements. Now then, let's rehearse this lot. I'd better not run out of time. The first point is easy to say and always overlooked. PL SQL supports all the SQL data types natively. And that means that the semantics are the same, up to and including all that stuff about null. I mean, love it or hate it, it is what it is, and it's there at the SQL level. And it's not unique to Oracle. I know Chris Date thinks it's a bad thing, but most people seem to think that the idea of nullness is useful. Tom Kite famously bangs on about the counter case where you represent a date you don't know by some thing in the big future, and then all your plans go wrong. So let's say that null is here to stay. Well, nullness is the same in PL SQL as it is in Oracle, or in SQL. Expressions, least, square root, you name it. Square root's perhaps not so exciting, but all these things, even width bucket. If you want to select width bucket, this, that, and the other from dual, you can use that in PL SQL in the same way. So then, that is huge, because what's the most conspicuous funny data type in SQL? It's number. Weird thing, isn't it? Why have we got it? It's because Oracle database is oriented at doing commercial stuff, and people deal with money, and they want it to add up in the conventional way, not in a kind of binary, not in a basic IEEE float kind of way, right? They want the normal rounding errors that you get when you count on your fingers. Pity we weren't born with just 2 fingers. It would have served lots of useful purposes, but the fact is that we're born with 10, and that there you have it. And that's what number's for. You know, you add 2 things up in number, all in SQL, select this plus that from the other. You know what you're getting, and it's what people want. No doubt about it. It's slow, but that's just the price you pay. People keep on talking about hardware implementation of that. Doubtless it'll come someday. And when it does, it'll benefit PL SQL just as much as SQL. And by the way, they don't have that elsewhere, do they, in the same way? So your arithmetic's going to be all funny if you're selecting number stuff into Java and messing around, you know. Most it can be is some add-on into it, which then has the same or worse performance as it does natively in Oracle. Okay then, so this is just the briefest example I could find that showed you a million things of phenomenal value. You recognize it immediately. It's a procedure that just has a couple of things coming in, and it's got a cursor for loop in it, and down the bottom it's just doing something. It doesn't matter what it's doing in the middle of it. And here we go. There we have the anchored declarations. The most important point about that is that that emphasizes the point of same semantics. But also it's a convenience, isn't it, for maintenance and all that. You know why it's convenient. I won't go on any more about it. R. What's R? If you think of how you do SQL method 4, you know, you spray this text over, then there's all this define business to see, you know, what on earth there is in the select list, and then there's all this stuff to do with associating particular values in your calling environment to go onto the select list, all that on and on and on and on. Ah, that's it. You just write it, and the PL SQL compiler sorts it all out for you at compilation time, so that all the code that corresponds to that subroutine level stuff is just brought in automatically. Yes? Huge. Phenomenal. What's that? That, at first glance, is a ordinary select statement that you could copy and paste into any other place that does SQL, most obviously SQL+. At least it is syntactically that. When you look more closely, the red guys are very likely, in fact you can discover that by reading the statement. There's no P floating around. No, that's wrong. There could be a schema somewhere called P. So you can't even immediately tell, but when you know the rules that we know, you can tell. So then, that's the magic, isn't it? You just write what you intend to mean, and the PL SQL compiler has a go in cooperation with SQL to work out that lot, and it finds, oh dear me, these 2 red guys escape. Oh, that's not a problem, because I've got them right here in my hand. And the result is this. That's the statement that runs. You can see it there in read_SQL. I mean, you can show it to your doubters. And it's got, what's it got in it? Colon this, colon the other, placeholders. Now, Tom Kite, bless him, seems to have been a bit dishonest somehow, because he's known that all the time, that when you use PL SQL, that comes out. Yet he's made a career out of travelling the world, first-class seats in first-class aeroplanes, luxury hotels, telling the world that encoding literals in SQL is a bad thing, and that binding actual values to placeholders is a good thing, right? Mainly focusing on the performance aspect of it, but also mentioning that when you encode literals, you're quite at risk for SQL injection. But look at this. How could you, in that piece of static SQL, end up encoding a literal? You can't. You can't get it in there. It just doesn't arise for you. So the thing that enabled Tom to live large and put his kid through college, as he is unashamedly proud of saying, is just impossible here when you use static SQL. And most of the time, static SQL is good enough for you. Right, moving on. Where's your open cursor? It's just implicit. More importantly, where are you closing it so you don't leave any dangling this, that, and the other? No sign of it. What happens if there's some error somewhere, like that buffer row thing goes wrong and you haven't catered for it and then an error comes all the way up. What happens? Are you left with a dangling cursor? No, the PL/SQL system does all that for you, right? It's just utterly implicit. When I say cursor implicitly closed, I should say cursor implicitly closed semantically, because here comes this point, soft parse avoidance. When people are banging on about binding to placeholders and the evils of not, and hard parse, you could be forgiven for thinking that hard parse is the only evil in the world, and if only you don't do it, life's perfect with respect to performance. But there's soft parse. What's soft parse? Soft parse comes after hard parse, isn't it? Hard parse is, loosely speaking, the thing that would happen if the text of your SQL statement was not identified as pre-done. But once you've identified it, that doesn't mean you're ready to go. You've got to find the child who goes with you. And that can be an expensive operation in itself. It's another searching. It's not as expensive as hard, but it's not free. It would be good to avoid it. Now, PL/SQL does avoid it because it leaves open the cursor, though it's semantically closed, that is associated with that statement location. So that, as is typical in ordinary life, next time you come back to that spot, the statement is super ready to go. The cursor is still open, there's nothing to search for, it's just there in your hand. The only thing to do is rebind and re-execute and carry on. Right? And no other thing provides that. This thing called, or the thing that's exposed to a parameter called session cached cursors, is an approximation to that. I mean, it's trying to do the same thing, but that still has to do some searching. It doesn't know about where the thing is in the statement, in the text of your program. This does. Okay? And by the way, that benefit applies also for dynamic SQL, given that next time you come around, you happen to have the identical text the last time you came around. And that's quite a common pattern. It had to be dynamic for some reason, but as you're going round and round and round it, it's not changing. So that's huge too. Bulkification. It just, there it is. You don't have to bang on about, go and read the books and read the blogs and everything. It is just doing the right thing under the covers. And it don't even have to obsess about how many is the right number. It's, science has shown that the the return on your investment in buffer size goes rocketing up and then it tails off. It's like in the old days when you used to buy your hi-fi equipment, if any of you remember that. Yes?
Can I ask a syntax question?
Yes!
I didn't realise you could do that. Is that correct? Where you're doing procedure name dot parameter?
More! Oh my God!
I've never seen that.
If there's one thing that gets on my absolute nerves, it's not here. I can't do it. It's this P_L_, right? And the reasoning behind that, if you scrape the surface, just falls apart. It's something to do with avoiding name capture, they say. And if you follow your own rules, then you will. P_ is the formal, and the thing in the table doesn't have a P_, and therefore you're never going to get a collision. It'll all be good. But then along comes fine-grained dependency tracking, and someone just adds a column to a table in the context of a SQL statement that was working perfectly fine, and suddenly your program goes invalid, and you say, what's going on here? I thought you've got fine-grained dependency tracking. And that's the possibility of name capture. How do we know that the column that you added isn't going to change the name resolution in general? Now here, every identifier in that statement is qualified. And that means that it's frozen. And therefore, this program won't need invalidation and revalidation. Doubtless the revalidation would happen quietly in your well-organized code, but it's an important point. And when you read it, it's more expressive, isn't it? P dot so-and-so than is P underscore so-and-so. It's not even conventional, it's formal.
How long has that been available?
Since the birth of time.
I don't think I've ever seen that.
Well, you've never read any of my blogs, have you? Or my white papers.
So the other question would be, though, there's no way to alias that, though, is there?
Alias. No,
Because
admittedly,
procedures are typically
if it's
quite
not
long.
P, but 30 characters long, it's a little bit of a pain. But then some things that are good for you are a bit of a pain. And I still recommend this. It's clear, isn't it?
Oh,
It
yeah, yeah.
says exactly what you mean. This is an interesting point. Native dynamic SQL. You very rarely need it at runtime in an ordinary application. When you need dynamic SQL, not so much when you don't know the name of the table, though that's true, but when do you not know it, if you've done a good database design? It's not like you have a different table for every state, is it? Is it? It's when you're doing DDL, creating tables and all that lot. When do you create tables and all that lot? Not at runtime, but at install time. How do most people install applications? Just statement after statement after statement in a SQL script that they run in SQL+, without any if-then-else going on in it. But the most conspicuous example of where a little bit of nominal if-then-else would help is this better approach to this ludicrous paradigm of, in any kind of installation, dropping the table you're about to create, so that the script just runs with a gazillion errors. And you have to read it, and you have to say, oh, yeah, of course, no, right, no, that was there before, well, how stupid is that? Really? When all you need to do is have one time you write it, drop table force, a little bit of exception this, if the table isn't there and you're trying to drop it, doesn't matter, because you said force, and then it runs silently. See what I mean? That's a trivial example, but if you just use PL SQL intelligently in install time, all manner of economies of scale and reuse and simplification and quieting down come into play. And of course, it's all one skill set. And all this lot is symmetrical. The bulk constructs and the for both, insert, update, delete, and selecting are symmetrical in native dynamic SQL and in static SQL. And moving on to this one, but of course, just to point out, we do have the subroutine approach if you really, really need it. Next point. Oracle errors are magically transformed to PL SQL exceptions. I won't claim that Java doesn't do the same thing, but now we're in the database. I guess I forgot to say, forgive me, that in the database, because you want to be in the database for the hard shell reason, there are two languages to choose from, Java and PL SQL. PL SQL was invented exactly for this purpose, Java wasn't. Java is a splendid language invented for a different purpose, and one of its conspicuous features is its standardization. Well, the standard doesn't include doing PL SQL by language features. So for that reason I excluded it. So the fact that Java does have that is just a curiosity, but it's very interesting that Oracle's PL SQL magically transformed Oracle errors into PL SQL exceptions. Okay? You never hear people use the terms correctly. This is another rant I have. But Oracle error belongs in one domain of discourse. It's what happens when a SQL statement goes wrong. Right? And it comes back as a code of some sort. PL SQL exception is just a control flow mechanism that it inherited from Ada, and many other languages have the notion of exception, and it's generally thought to be a good thing. And the whole PL SQL system translates every Oracle error that comes back to it into an exception. You may or may not have a handler for it, and if it gets all the way to the very top, it goes back the other way and comes out the top as the error it first was. But as it's bubbling up as an exception. So it really serves clear thinking to distinguish in usage between Oracle error and PL SQL exception. Right then, definers' rights and invokers' rights. You all know what it is. The brief thing to say here is that without definers' rights, that hard shell wouldn't be hard. With it, it is. And we've got that. Java has it too, but we already eliminated Java. So the essence of the hard shell depends on the definer's rights. The invoker's rights is a little bit out there. It's most useful for various exotic things, like doing certain powerful DDL type of stuff, where you expect that the user will have the privileges, but you want to enforce or support some practice, like all index rebuilds are always done with the online keyword. That's a kind of use for invokers' rights. Right then. No make! I never hear anyone talk about that either. But just think about it. if you didn't care about efficiency, you could just spray in the DDLs who establish all of the objects you're interested in a completely random order, getting all sorts of errors along the way, and then you just press the big sorted out button, and if, assuming now your scripts are right, which they would be, then it'll all calm down and everything will be fine. And then, as a side effect of all that sorting out, the dependency graph is established. And that goes in hand with a promise that if you try to execute a PL/SQL unit, or subprogram in a PL/SQL unit, either you can, if it's valid. If it's not valid, you can't. That's the requirement. You can't even get off the ground if it's not valid. And you get a simple, clear error saying, sorry, I'm not valid. Now, what does validity and invalidity depend on? How does it all go? If you go on an invalid guy, then behind the scenes, the database tries to chase all the things and sort it out. If it can, you never got to hear about it, except it's a bit slow. But if you can't, well, it can't. And the other way is more interesting, that if any item in that whole, in general, very large transitive closure of dependency parents that your guy is standing on, if any one of them changes in some way, there's a chance that you'll go invalid. Fine-grained dependency tracking might mean that you don't, but there's a certain chance that you would. Maybe it can all sort itself out, but if it can't, it won't. But if it does, then you know something. And you know what you know all the time whenever you run something, and that is that it has been checked against everything it depends upon in the whole transitive closure in its current state. And that's what makes all about. So Oracle just magically looks after that for you without you even thinking of it, which is again an overlooked bonus. Developer productivity. Okay, and I think I can more or less do it because I was granted extra time for Tim's interrupt. Every single artifact that implements the business functions, and I mean everything now, it's just there in that one universe, inside the Oracle database. And there's a homogeneous scheme for all its metadata. The metadata for everything you care about, right? There's metadata for everything, static definitions and runtime behavior. Homogeneously available. How do you get at it? Do you have to learn some new techniques? No. You query it up with SQL. If you want to pretty it up a bit or do two things in a row, you encapsulate it in PL/SQL. That's what you do all day anyway for your day job. So it's just all harmony, all goodness. If someone asked you what's the benefit of looking in any one of those, you could give a good account. I'm not going to go through it, but you know what I mean. But DBA source, just think about it. All kind of patrolling you can do for all kinds of things. If you are good at regular expressions, all kinds of enforcement of all kinds of standards, just like that. And it's the joint world of the tables and the code, isn't it? You don't get that in any other way. What else have I got in there? Somewhere there's identifiers, DBA identifiers. We've got this scheme called PL scope. If you ask for it at compile time, you get the complete story of where this identifier is defined and who refers to it and what kind of usage it is, everything. That's quite, and it spans tables and procedures and everything. Okay, and not only that, but the whole runtime world is exposed in the same way. And some of it is just exposed implicitly, life goes on and these things get populated. Others of them, you do it more deliberately with various kinds of tracing things, including DBMS trace and DBMS hprof and DBMS profiler, you name it. Okay. So the fact that there's metadata for everything is huge. Of course, everything else you'd expect is there too. IDE, all that thing, compiler warnings, conditional compilation, you name it. But it must be said that compiler warnings are sensitive to SQL. So you might get a warning saying you're doing implicit data type conversion and that could screw up your plan, which you don't get in other environments. That's not a bad thing. We'll be saying soon, oh, you're using a hint. Are you really, really sure you read the right books? And conditional compilation can test package globals. That's another. It's right there in the database environment. That's another huge thing. I won't dwell on it now. So then, quickly on this bit, and then we can get through. You did used to hear, well, that's all very well, but if I want to patch something,
I can't do it. All this package state discarded, all this couldn't get a lock anyway, or who knows what. Of course, at some point in time, that was true. I can't deny it. But it stopped being true in 2009, which in the lifetime of a framework is, an epoch, isn't it? It's huge. So these days, if you want to change PL/SQL code, and in fact, anything at all that has to do with your whole environment in the database, you can use edition-based redefinition. I'm not going to teach it now, even though I'm the product manager for it, and I could suddenly now take a 3-hour parenthesis on just that without stopping. I'd be delighted to, of course. I won't. It solves the problem. It just goes away. And the interesting thing about EBR is that in order to be good at it, you need to be good at SQL and PL/SQL. It's all just one story. And it's where it belongs. You know, the interface in a lot of cases of patching will be untouched. All sorts of stuff will go on behind it. The outside world doesn't even know this is happening, and what's more, zero downtime. You couldn't say it better than that, could you? And then finally, how often do I hear these strange stories about the development DBA and how I can't get any development done because the DBA won't let me have a column and God knows what. And people trying to write code in the environment of other people trying to write code where the purpose of the code is to change the data, and your fucked up code changes the data and they think that their program's broken. It's madness. Every individual developer needs their own private space populated appropriately. And that would just shift the focus on how development is normally done. The final deliverable from the development shop is a corpus of scripts, isn't it? In some set of appropriate languages that can be mechanically consumed either to install or to patch the production thing you care about. And how do you get that corpus of scripts? Because you've got a repository for your corpus of scripts, a source control system. How do the things get in there? Because people check them out and they can't put them back in until they get committee approval if you do things properly. Right? So it doesn't matter what you do. You could do it all in your head. No one would know. If you're a genius, you wouldn't need any environment. You just check out a source code file, make some changes in it, check it back. It has to get through the police. But if it does, no one will know if you're a genius and doesn't need any kit. Or, see what I mean? That's the metaphor, isn't it? How do you get that? Oh, by the way, I forgot to say, sorry, Oracle eBusiness Suite uses edition-based redefinition. It's been doing it in production for 2 years. Well over 100 famous name customers in production with it. If they do it, Salesforce is doing it. They gave a talk at Open World last year. American Express is doing it. They gave a talk this year. If those big guys can do it, anybody can do it. If it can be used in the complex world of eBusiness Suite, it can be used anywhere. Moving on, then, to that point, right? Sorry, I forgot to say that. PDBs as sandboxes, right? Now, in some ways of doing development, just a private database isn't enough, because you've got all manner of daemons and who knows what, and they have to all be in place so you can work. But if we focus on this paradigm, the thick database paradigm, there'll be a gang of people whose entire life is just done inside the hard shell, behind the hard shell. And their environment needs are served exactly and only by a database. And guess what? Pluggable databases are such databases. And two interesting things about them. One, on the right infrastructure, they enjoy this thin provisioning scheme, which means they don't take any space until you change one or two things, and it's only the changes that take space, and the initial copy is instant. That's one good thing. And the other is that the whole way you manipulate them is with SQL statements. Guess what? One SQL statement is not enough to do what you want with a pluggable database, but several are. How do you put them together? PL/SQL in the database. So you can, and of course the way you want to operate will be very shop specific. You know, Tim maybe is only allowed to clone such a database, while Neil there is allowed to clone a different database. Who knows? We couldn't ship such a system, but if you know how to write a trivial Oracle application and all SQL and PL/SQL, you can sew up the bits. And probably it's good enough to expose the whole provisioning scheme as commands that you would operate with in SQL Plus. But if you want, you can, have at it. Do it in Apex, I don't mind. It all flows together, doesn't it? But now just think. There we have that. You can just then do the whole cycle, can't you? You've got your latest stuff. You want to see if it works. You can mechanize the whole thing so that you just create a brand new database for it, run it through, all sorts of things you write out because that's how you know it works. And then you just set the thing back so you can start again. The whole thing can be mechanized, and the whole thing can take not much longer than your actual test itself. Yes? And when I started in this life, I was typing up my program after having written it in handwriting on a card punch and taking the cards down into the room on a trolley that I built myself because you couldn't get anything that was quite right. And all the cards had, felt pen X's on the top and all that stuff, so that if you dropped them, which you occasionally did, you had a chance of putting them back together. Then you put it in the room, and 24 hours later, if you're lucky, you get the results and you can see they're wrong. If you're unlucky, you did a spelling mistake and the whole thing didn't get very far. That was the cycle, and it's hard to keep your train of thought going under those circumstances. Similarly, if you got all your stuff, you in some way or other, you managed in some test environment to compile things up and fairly quick and easy using Secret Developer, but you still have to wait a long time till you can really, really be sure because of all the other stuff. It's crazy. But now, the same transition, where difference in degree becomes a difference in kind for basic program compilation and testing, is now brought to the whole Oracle database environment. So then, as I said, a difference in degree becomes a difference of kind. We're more or less ready. This is the main point. Now, I think we're now ready to stop around with these silly terms like database, DBA, and developer. Say, I can't get the development done because the DBA won't let me. There's a development shop, isn't there, and a deployed site. And ultimately, the guy running the deployed site does lose his job if he didn't check everything that's about to be done and promise and agree that it's all right. And if it doesn't quite work, he'll be the one under the spotlight sorting it. But that whole stuff that he's running through got built in the development shop. And one major part of it is the database module, right? And the database module is developed, and the skills you need are first, ordinary requirements analysis with respect to the basic data-oriented functionality. Never mind if the screen's going to be blue or green. Never mind if the beach ball is going to spin or if it's an hourglass. And you need, from that, information analysis and data modeling and schema design. In this thick database paradigm, it must be said that the names of the tables are in your world. You know what they are, you know what the columns are called, you know about the data. It's all very visible, and it got like that because you designed it like that and put it there like that. It's stupid to call that DBA. God knows why people do. The whole community of Oracle database development engineers are delivering the whole shooting match that includes the schema design and the functionality that goes with it as a set of scripts, either install from scratch or patch. Right? So we've got a crystal clear job role definition. The Oracle database development engineer. And that's the community of people who work behind the hard shell to make the hard shell show off what it should. There we have it. What they can is the stuff I said. If they know about RMAN and DataGuard, I'm happy for them, but that's not an essential skill for that job, particularly with PDBs for self-provision. Someone once set up the whole scheme, and now we're good to go. So then, let's conclude. They always say that you have to have 3 points. So I will have 3 points. And this is the most compact and maximally unassailable way I can think of saying it. If you've got an Oracle database in the picture, it's there for one reason, persisting stuff. It's persisting data. And that implies that the data is important. If there was nothing to persist, it would be a different discussion. Then it would be some thing on the iPhone for playing games or something, but that's not what we're talking about. So an application whose purpose in life is to persist data in an Oracle database and to get it back and show it right is worthless if it doesn't do that. As Clinton would have said, it's the data. That seems unassailable to me. Next point. The way to achieve that is to protect it all behind a hard shell. That is only the natural embodiment of the wisdom of modular program construction, which is as old as computer science itself. To put it in detail, select, insert, update, delete, and the other things, commit and so on, come only from PL SQL. It's the time-honored way. It's what they were doing in the 90s, and nothing has changed to make it suddenly a bad scheme. On the contrary, as more and more diverse things crop up into the outer world, the hard shell notion becomes more and more important. And then, as an add-on, as a luxury, only when you've ensured that your world is not boxed up, is it appropriate to start to talk about its performance and security characteristics. And just by virtue of the fact that all that stuff is in the database, that you can't get away from binding the placeholders, it's all implicit, that the round trip duration is all contained within a single process, all that stuff means that you've got good performance and good security. All the things that you hear at the conferences about how things go wrong are just not able to happen in this world. So there we have it. That's what we should see. The thing bursting through the roof is the trade of Oracle database development engineer, as I defined it. Thank you for your attention. Obviously, I'll take questions either at the front or over the long-promised and never-appearing samosas. Yes?
I'm totally with you, 100%.
But,
The two arguments
yes,
that I hear repeatedly for this.
yes, right. You mean for it or against it?
Against it.
Yes, yes.
And I just wonder what your take is.
Yes.
First is that most shops now don't just run Oracle.
Yes?
So that lie of database agnostic,
Yeah.
which everyone knows doesn't really work,
Yeah.
but people still try to achieve.
Okay, shall I take that one now?
Yeah, sure.
I can simply quote the now retired on his riches, his ill-gotten riches, if you ask me, Tom Kite, because he only referred to the principle of modular software construction. One of its strengths is that when you've established that modular decomposition with clearly defined interfaces, you can switch out a module with ease. Now, admittedly, the spelling of the invocation of functions in one vendor's world might be subtly different from in another. But nevertheless, the functionality is expressed in that abstract fashion, implementation independent fashion. The interface doesn't reflect, let's say, zero-length string semantics, which famously varies. It doesn't reflect locking strategies, right, which differ from vendor to vendor. It doesn't reflect various things to do with read consistency, which even now, to some extent, differ from vendor to vendor. If, on the other hand, you're simply spraying SQLs at the thing, one, there'll be a lot more individual SQL statements than there are members of a functionally oriented interface. And number two, you have to think very carefully about the semantics of each one and how those semantics change as you go from vendor to vendor. So in fact, the idea that using only insert, update, delete, and so on brings vendor independence is a myth. What it brings is guaranteed problems and a lot of effort if you try to move, while the hard shell thing delivers you up with a very finite proposition. And in particular, if you realize, when you come to consider how such a business function that works splendidly in Oracle couldn't be implemented satisfactorily, you haven't done any code yet, you're just thinking about the semantics of the new environment. When you realize it can't be done, you've learned something very valuable immediately, rather than finding out hugely downstream when all sorts of mysterious corner case errors come about. So I think that argument...
You can see how it can be compelling for, say, a Java developer, though,
yeah,
to use a framework that effectively gives them that sort of one-size-fits-all.
Yes.
Even though
yes,
it's discussed.
Well, there's ultimately there's what I said,
Yeah.
which is a logically developed argument, and there's the other viewpoint, which is an emotional response. It's the difference between studies have shown that there's a large statistical correlation between doing certain bad things, like smoking heavily, and dying, right? And then the counter argument is, but I like it. And I really, really like it. And I'm not going to stop because I really, really, really like it. Well, ultimately, there's no unification of those two viewpoints, is there? But I know which one of them I find convincing.
So my second
Yes.
point, the argument you hear all the time, and I have some sympathy with this
Yeah.
to a certain extent, is that there are a whole bunch of tools out there that work really well with having direct access to the tables, and not so well by constantly just calling store procedures. And I mean, you can even take something like Apex, where yes, it works pretty well with store procedures. Yes, you can use pipeline table functions to expose queries so that things like interactive reports work well. But there's a whole bunch of functionality that works really nicely if you give it direct access to the tables. And once you do that for one tool, it ends up becoming the standard for all of the tools.
Yes, of course I've heard that, and I don't have such a compelling argument against that. It's just like sometimes life is like that, and you have to take a more traded decision. And the first kind of level of concession is that a database that exposes its change-oriented functionality through PL/SQL procedures and its reading functionality through views, which by all means can be direct views without any table function in them, is still worthy of the name hard shell. Now, it's not even clear that the use case for pipeline table function behind the view is that strong. So that would be the first step. And I know the famous Tone Copeland has done a lot of practical work with practical jobs for clients in that space, and still adheres to the thick database paradigm. I should have said that I've stolen everything I said here from him. It's not like I made this stuff up. And of course the people who invented all this stuff, like Andy Mendelsohn 30 years ago, so 20, yeah, almost 30 years ago. So that's the best I can do there. It's slightly weaker, but then you can refer to successes and failures. Now I'll ask you then. You all said that you know PL/SQL. I'll ask this formal question, and I know that one person would say yes to one of it. Did you learn anything of substance about PL/SQL in what I said? P-dot. Yeah. Well, that's something.
I'm going to call all my shit P from now on.
Yeah.
That's why I do P-dot.
What you can do, and it often is surprisingly natural, is make a much more deliberate use of PL/SQL's block structured nature than you tend to. You can have a declare what they call a block statement, a block compound statement at any level. You can give it a name, I don't know if you realise that, double brackets, V, double brackets, and then you've got a little letter space. And you can declare things in it, and a lot of time that's good enough. Okay. So I'm assuming that apart from that you didn't learn anything about the PL/SQL, so the final question, because you didn't need to, because you know it, is do you think that you could benefit from studying the white paper, which is basically what I said, and then delivering its message with conviction, the way I did today?
Tried it year after year,
Yeah.
lots of different sites. One or two work really well.
Yes.
But the fashions were
You mean
so
that you
bad.
didn't hear anything in this arrow of
I
development?
I thought the explanation of hard shell was particularly good.
Yes. Something that you've used yourself, or not?
Not that example,
Right.
but I've pushed. You pushed.
Well, I'm going to take that as a little win then. I have given you something.